Hello everyone, let's solve minimum time for k connected components. It's a very interesting problem. Let's see how can we solve it. You will be given n nodes labeled from 0 to n minus 1, and you will also have two-dimensional edges array which represents time it takes to remove edge between node u and v. You will be given an integer k. Find out a minimum time to remove all edges in order to make at least k connected components. So this is the expected result. Let me walk through an example. Let's say you have given edges 0, 1 and 1, 0, 1, comma 2, 1, comma 2, comma 4 and k equal to 3 and n equal to 3. As n equal to 3, so you have 3 nodes labeled from 0 to n minus 1. And he has given edges. To make a edge between 0 to 1 or to remove a edge between 0 to 1, it takes time 2. To remove edge between 1 to 2, it takes time 4. So we want to make k connected components, right? So which means k equal 3 here. First, let's understand how many connected components it is. It is one connected component. You see all the nodes are connected, right? So we can call it as single connected component. So in order to make three connected components, let me try removing minimal edge, which is 2. So if I remove that edge, then it becomes 0, 1, 2. 0 to 1 to 2, there is 4, so you have 0. Now if you closely see, I could see that there are two connected components. This is one component, so these two nodes are connected to single edge. So this is one component, and we have one more component 0. Still, I couldn't make three connected components, so that I need to remove one more edge between 1 to 2. So if I remove one more edge between 1 to 2, then it becomes 0, 1, 2. Now if you closely see, I have three components. So they have three components. None of the nodes are connected, so that all are three components. So the minimum time it took is 4. So the expected result here is 4. Okay, let's see. Hope you understand the problem statement. Let's see how can we solve it. Let's say you have given n as 4, and we want to find out uh, two connected components. So we need to find out minimum time in order to make two connected components. So let's say these are the edges you given. If it is a brute force, so let me try with brute force so that we can move on to the optimistic solution. Let's say it is a brute force. How do you do that? So I want to find out a minimum time, right? So within the edge, you have u and you have v and you also have time. So there are three values within an edge. So what I do, I need to find out a minimum time. So that what I'll do, first I will sort based on time in ascending order. So based on time in ascending order. If I do that, so how it look like? I get 1, 2, 5 because this is the minimum edge. Later you have 1, 2, 8. Then later you have 2, 3, 12. Then 0 to 13. And finally you have 0, 3, 14. So this is 13, then this is 14. Right, so we got all the 5 edges. So we got all the 5 edges. So how do you make it? So first what you'll do, right? So if you want to know the number of components, the best way to construct a graph using union find. So, and you know that if you would come up with best union find solution, so find and union method will always take constant time. So first, let's say I don't want to include this edge as this is the minimal edge, right? How do you know that this is a minimal edge? Because it is taking minimum time. So let's not include this edge. If you don't include this edge, let's construct a union find graph using remaining edges. So I don't draw any table here, but rather I'll just connect it. So let's say I will make a connection between node 1 and 2. Okay, so done. So then I'll also make a connection between node 2, 3. So node 2, 3. Then I'll make a connection between 0 to 2. Okay, 0 to 2. Then 0 to 3. And you also have 0 to 3, so which is 14. Now if you see, If I don't include this edge, if I don't include 1 comma 2 edge, let's see how many components I could make. If you closely see, this total includes four nodes, and it is a single component, right? Because all the nodes are connected. But I need two components now, so that by removing this edge, I couldn't find a solution. So let me construct by removing second edge. Okay, so if I remove this edge, then I need to construct a graph using union find or any other DFS. But union find is the best way to do that. So for remaining edges, these are the remaining edges, right? So let's do that. So I have remaining edges. So one is 2, 3. Okay, so let me make a. I have I have 1, 0, 2, 3, right? So if you see, I am not considering this edge, means if I don't consider till part, with remaining edges I am trying to construct with 2 to 3. So I'll make it 2 to 3. So it took some 12. So and 0 to 2. Okay, I'll also make 0 to 12. And you have 0 to 3. So this is 0 to 3. Now if you closely see, right, if I don't include this h 1 comma 2, then if you closely see how many components I could make, so this is one component and this is one more component. So I was able to make two components which is equal to k. So obviously I got the expected result, so that I can return this time the time which is 8. So that here the expected result will be 8. So the 8 will be written here. Now, what is the time complexity? If you see this brute force approach, right? What is the time complexity you could see? What I'm trying to do, what I'm trying to do, let's say you have m edges, total m edges. So first m edges, you are trying to first if in this case you are trying to create a remaining m minus, we are trying to create a graph with remaining m minus 1 edges. Then when you move on to this index, you are trying to create a graph with m minus 2 indexes, right? So, or m minus 2 edges. So similarly, if it is not possible, you look for other opportunities. It means if you see m1 into m minus 1 plus m2 into m minus 2 and so on, right? So to create a graph, right, to create a graph with union find, it is always going to be constant. So union operation takes constant time, find also takes constant time, so that you will have m1 into m minus 1 and so on. So you can take it as m square. So just like this, to create a graph itself, it is taking m square. Before that, what are you doing? We are also sorting it. So let's say you have m edges. So what are you doing? So you are doing sort plus you are also creating all possible graphs, right? So all possible graphs to find out the components. So what will happen? So for sort, it is going to take, let's take m edges, it is going to be m log m plus all possible graphs, which is going to take m square. So this is the time complexity we get if you go with brute force. So m log m plus m square. But can you optimize this? Can you optimize this? Yes, we can do that. Let's see how can we do that. So that is where the tricky of reverse union find. Let's do that. So this is the input we have. So let me copy this input. So let me paste here. Yeah, so this is the input we have. And so what is the mistake we are doing? So we need to avoid that mistake. So in an optimistic solution, so it's a simple tricky part. We are going with same union find itself, but we just do a little logic. So what is the mistake we have done? So when we try to do other solution, right, what we did, so first we skip this, then we try to see all possible. First we try to construct a graph through union find and see all possible ways. Then we try to consider skipping till here, and we are try to construct a graph for remaining things. So if you, in worst case, we try to see possibilities for each and every edge, right? Rather than that, if you closely see, this is our valid result, right? So this is our valid result. Yeah, so this is our valid result. If you closely see, whatever maximum time, right, which is part of the graph, right? So 14, 12 at 13. So these three are max times, right? So these three are the max times if you see. 13, 14, 12. These three are max times which are part of the connected graph, right? So which are part of the connected graph. The minimum one which is the actual answer, which is not part of the connected edge, so that you got the number of connected components as 2. So the same technique what we do, so what we do, we will sort based on time in descending order. Okay, so what we do first, sort edges based on time in descending order. Okay, so let me do that. If you do it, how does it look like? So just take the 0 to 3, which is 14. This is a maximum. Then you have 0 to 2, which is 13. And we have 2 comma 3, so which is 12. Then we have 1, 2, which is 8. And finally, we have 1, 2, which is 5. So we sorted based on time in descending order. Okay, fine. Then let's say what are the number of components we have. So number of components. Let's say you didn't make edge between any one of the node. Then the number of components is equivalent to n. So by default, which is 4. So in this case, you have, it means you didn't made any connection between the edges. So you have 0, you have 3, you have 2, and you have 1. So we have total 4, right? So these 4 are independent. So it means you didn't make any connection between these nodes, so that the number of components is equivalent to 4. But we are expecting what? 2, right? Let's see how can we do that. So first we make a edge between 0 to 3. So okay, can we make a edge between 0 to 3? So when do you make a edge between 0 to 3? If they are not connected. So 0 and 3 are not connected, so I can make a edge between them. So that if you see, as you make a edge between them, it means you can decrement the component value. So earlier it is 4, you can decrement by 1, which is going to be 3. Even if you see, so these two are connected as a single component, and this one and this one. So we see total we have connected components as 3, but expected result is 2, right? Okay, let's see. Let's go further. Then we move on to the next use case. So we have 0 to 2. So let's make a connection between 0 to 2. Can we make a connection between 0 to 2? Yes, we can make, because they are not connected earlier, right? They are not connected earlier. So we make a connection between 0 to 2. So now as you make a connection between them, so it's time to decrement the components. So earlier it is 3, by decrementing it is 2. Now if you closely see, you have you have two connected components here. But the point is what? We need to find out the minimum time, right? So this is not the right time to know what is the minimum time to make a connected components. If you closely see in the earlier diagram, right, whenever you are skipping the edge between 1 to 2, then you are able to find out a number of connected components, which is with the time 8. So that 8 you return. So now we are moving into reverse direction, right? So let's see, you will get clarity here. Number of connected components is 2 now. So now let's move on. So let's try to make a connection between 2 to 3. So can you make a connection between 2 to 3? There is no use, right? Because 2 and 3 are already connected. 2 and 3 are already connected through 0. So they are already connected. Even if you make a connection, there is no change, right? So even if you make a connection between 2 to 3, there is no change, because they are already connected through 0. So they are already connected to 3 0. So we will decrement this number of components only when you make a new connection. So in this case, 2 to 3 is not a new connection, because 2 and 3 are already connected through 0. So that's why there is no change in number of connected components. Here also you have 2, earlier also we have 2, with new connection also there is no change. Now this is where we need to think. Now let's move further. If I go further, so which is 1 to 2, right? So we need to find out, can we make a connection between 1 to 2? Yes, I can make a connection between 1 to 2. So we need to find out what is the triggering point to make two connected components, right? So that can be done whenever your component value is less than k. Whenever your component value becomes less than k, then you find out a right answer. So in this case, if you see till here, till we come here, it means till we come this point, So now we are trying to find out a solution for this. Till we come this point, our number of components still 2, which is not less than k. K also 2, right? We need to find out a value which is less than k. That is going to be the triggering point to distribute your graph into required components. So let's say you want to make a connection between 1 comma 2. So okay, can I make a connection between 1 comma 2? Yes, I can make a connection between 1 comma 2. So when I make a connection between 1 comma 2, it's time to decrement number of connected components by 1, so which is 1. So if you closely see, even if you see the diagram, so the number of connected components becomes 1. So whenever the number of connected components becomes less than k, so whenever your number of connected components less than k, then that edge time is going to be your answer, the edge time. So the for 1 to 2, for 1 to 2 the edge time is 8. So you just need to return that edge answer. Hope you understand this. So this is a very critical point. We are trying to do reverse disjoint set union, so we are doing in reverse direction. So we need to find out what is the edge which is making my number of connected components less than k. So that edge time is going to be the answer. So hope you spend little time on it to get it. So this edge, right, this edge is dividing the graph into two components. So find out that edge, return that time. Now let's see the time complexity here. So let's see the time complexity here. So what are we doing? Let's say you have m edges. So you are doing sorting so that it is m log m. Plus, we are trying to create a graph only once, right? So for m edges, we are trying to create a graph only once. So we are just trying to create a graph only once. So obviously, this graph time is always going to be constant in on and average, so that the time complexity will be m log m plus m. That's it. So this is our time complexity. And what is the space complexity here? So what are we doing? So we are trying to construct a graph using union find. Okay, so using union find. So we know that how to do that. The union find, generally it is going to take number of edges, sorry, number of nodes. So the number of nodes are represented as n, so which is going to be big O of n. So the space complexity for this problem will be big O of n. That's it. Hope you like the explanation. So let me go and write the code so that things will be more clearer. So what I'm trying to say, I'm going with union find. So union find, then you are having integer array root, then you will have union find, and you will take the size. Okay, then our root is going to be news in given size. Then initially every component is independent, sorry, every node is independent, so which is starting from 0, node less than size, node plus plus. I'll just write root of n is equal to n. That's it. We construct a union find. Okay, so then we are trying to find out a root of each and every node, so we can call it as x. So you know this, if x not equal to root of x, then you need to find out its parent. So find of root of x. So this is path compressions. Hope you are understanding it. If you don't have idea on construction of union find, I already made a video on it. So please take a look into it so things will be clearer. So root x. That's it. So this is a find method. So let me write a union method. So public boolean union, so which is taking x and y, and take root x as find of x and root y as find of y, and see if they are already connected, then both the roots will remain same. If they are already connected, then you can return false, so that this is a tricky point. And if they are not connected, then just consider root of root y, which is equal to root x. Finally, you can return true. This is common logic of union find. Hope you get it. And even this find operation on and average, going to take constant time because we are using path compression, and union operation is completely depending on find, so which is also taking constant time, and construction of this union find is going to take linear time, but it's fine. Let's move on. Now we need to find out the minimum time, right? So first what we should do, so sort uh, based on time, in descending order. Okay, so first we sort in based on time in descending order, complete edges. So whatever edges you have, you just need to sort it. So I'm just doing arrays dot sort of, these are the edges. So I get edge 1 comma edge 2. Simply I'll just need to do reverse. So integer dot compare of e2 comma 2 comma e2 of 2 comma e1 of 2. That's it. I just reverse the sort logic. So it just sorted. Then what is the next step now? So we need to find out number of components. By defaultly, the number of components is equivalent to n. So by defaultly, every component is independent, right? So by default, it is n. Then let's create a union find with the given size n. Then what is our job? Now it's time to make a edge. So you have edge from edges, so which is coming in reverse order based on the time. So first you get x, which is edge of 0, and take y, so which is edge of 1, and take time, so which is edge of 2. Now let's see first, can you make a connection between them? So union of comma x comma y. If you are able to make a connection between them, it means you reduce the number of components by 1. Now it's time, right? So if number of components is less than k, it means you, this is the current edge which is distributing the k components, right? So that you can directly return that time. Hope you get this point. So generally people tend to get confused here, but this is the point where this is the edge which is making distribution between k components, so that just return time. So otherwise, you at last, if none of the edge you found, you can return 0. That's it. So hope things will clear. So let me run it. Let me submit. Hope you like the explanation. Thanks for watching. Please do subscribe and share. See you next time. Bye.